All right, so in this video, we are continuing our study of spreadness, and we talked about that was looking at first the range, then we said, well, there's got to be a better one. Then we looked at interquartile range, got to be a better one. We looked at the mean absolute deviation, there's got to be something better, and so here it is. The best way to measure spreadness is going to be the variance, but more importantly, the standard deviation. But these two do go hand in hand. You need the variance to find the standard deviation and vice versa. So here's our first example. I've got the steps on the right and then the example on the screen. Find the variance and standard deviation for the following test scores. So here are my data points: 99, 67, 84, 99, 67. And so in my first column of my chart, I'm going to list off the data. Now, you don't see the actual standard deviation and variance formula, but what the formula says is that you're going to take the data, find how far it is from the average, so subtract the average from the data, x minus x bar, or the average, and then you're going to take that number, x minus x bar, what you found in this middle column, and then you're going to square that. And the reason I square it is because distance, I need to be negative. So when I subtract off the average, sometimes that number is going to be negative. I can't have negative distance, so if I square it, that's going to make all of these values positive. And then from there, I'm going to find the average of all of those numbers. And so those steps are over there. It makes it much easier if we just see it in the table. So the first column is always going to be my data, and I took these and I just wrote them in the order that they appeared. You don't have to do them in any special order. If you want to put them in least to greatest, that's fine, but just put them in the order itself doesn't matter. Second step says subtract the mean from each number. Okay, well, to subtract the mean, I need to find the mean. So I've already found that for you. That goes back to what we did in the beginning, and so I'm going to find the mean and add up all the data points, divide by 5 in this case because n is 5. Oops. Because n is 5. Now from there, we're going to do the first row together, and then I'm going to show you the rest of them so that you can pause and check. So the first row, step 2, subtract the mean from each number. All right, well, my number is 99, that number right there. Subtract off the mean, minus 83.2, because that is what I have for the mean of this set of data. And then the next thing says square the difference. Square the number you just found in the previous step. And so the number I just found was 15.8. When I subtract those, and then I'm going to square it and get 249.64. Make sure that you do put these numbers in parentheses, especially if it's negative. That will matter in the end. This whole column should always be positive numbers. All right, so what I want you to do is pause the video, finish out the rest of this table, and then resume and check with mine. All right, so with your table, you should have gotten this. So check all of those. Pause the video again. Check all of those numbers. And that's just doing the same thing over and over and over again for each row. From there, my steps say, okay, now that you have squared all the differences, that was what we did in that last column, take the average of those differences. So average up what you just found in step 3. So I'm going to take all of these numbers, and I've highlighted them purple. I've highlighted them yellow. I'm going to take all these numbers and average them, meaning that I'm going to add them all up, and divide by the number, in this case, 5. Once I do that, I get a variance of 204.96. Okay, so that's to here. That is number 4. Average those differences. That is going to give you V. So it says called V. V stands for variance. And then to find the standard deviation, I'm going to take the square root of V, which is what it says in step 5. To find the standard deviation, I'm going to take the square root of the variance, square root of 204.96, and that is going to give me the then standard deviation. The reason that I don't really look at variance much is because this is units squared. So in this, I'm looking at test scores. So this would be percent squared would be my unit. Percent squared doesn't make sense, but if I square root it, I've now canceled out that squared, and now I'm back down to percent. So we really look at the standard deviation as a whole just because the units match my data. And so what this says is that the data is not horribly spread out, because a bigger variance would say a bigger spread of data. So with that, let's compare two charts, two classes, to see which one has a higher variance. All right, so I've got two different classes. Determine the variance and standard deviation for the following, and then it asks me the question, which class should have the largest standard deviation? Well, as I'm looking at these, Mr. Abel's class, his grades are 100, 80, 70, 50, 50, 10. Versus Mr. Babel's class, 70, 70, 60, 60, 60, 40. Because Mr. Abel's class has a bigger spread of data, it goes all the way from 100 to 10. Mr. Abel will have the bigger variance, the larger number for variance, and the larger number for standard deviation, because it has the larger spread. So what I want you to do is I want you to pause the video and see if you can find the variance and the standard deviation for each. Before you pause, I want to do the first row of Mr. Abel's class just to remind you. I've got my data down the left-hand side, and then in that first column, I'm going to subtract the data point, 100, which came from right there, minus X bar. Well, I went ahead and found X bar for you. And X bar is going to be, or the average for this one's going to be 60. And when you unpause the video, it'll all be there, but just so you have it. X bar is going to be 60 for this one. And then I'm going to subtract those two, get a 40, and then in the next column, square it, and I will get out 1,600. I want you to go through and finish out Mr. Abel's class and Mr. Babel's class. All right, so you've unpaused the video. Here's Mr. Abel's class. Here is the variance, which I got of 800, and then the square root of that gives me a standard deviation of 28.3. All right, from there, here is Mr. Babel's class. And then let me do that first one to fill that in. 70 minus X bar is 70. It's going to give me 0. And then 0 squared is 0. All right, add all that up. Divide by 6 in this case. By add all that up, I mean add up all of these differences and then squareds. Add them up, divide by 6, and get a variance of 100. Take the square root of that and get a standard deviation of 10. So just like we expected, Mr. Abel's class has a higher standard deviation than Mr. Babel's class, because Mr. Babel's class, their grades are pretty close together. They only go from 40 to 70, Whereas Mr. Abel's class, he had someone get a 100%, but also had someone get a 10%.